An object moves along a circular trajectory with a uniform angular speed of 0.8 radians per second at a constant linear speed of 4 meters per second. What is its acceleration? Solution: the angular speed is 0.8 radians per second. The linear speed is 4 meters per second. We want to find the acceleration. That is the centripetal acceleration. So we know that acceleration is equal to v squared divided by r, or acceleration is equal to omega square r, or acceleration is equal to the product of the angular velocity and the linear velocity. So if we want to use the formula that have r, it means we should first find r. So let's try to find the radius. Using v is equal to omega r, to find r, we divide both sides by omega. So this will cancel this. It means r is equal to v divided by omega. So what is the linear speed? It is 4 meters per second divided by the angular velocity is 0.8. So 4 divided by 0.8 is 5. So it means the radius is 5 meters. So since the radius is known, we can use any of the two formulae that has r in it to find the acceleration. Okay, so using acceleration is equal to v squared divided by r. The velocity is 4, so that will be squared, divided by the radius is 5. We're going to have 4 squared is 16 divided by 5. The answer will be 3.2 meters per second squared. So using acceleration is equal to omega square r, we know that the angular velocity is 0.8. That will be squared, multiplied by the radius is 5. So 0.8 squared multiplied by 5, you will still have 3.2 meters per second squared. Or using the simplest, acceleration is equal to omega multiplied by v. The angular velocity is 0.8 multiplied by the linear velocity is 4. So 0.8 multiplied by 4, you will directly have 3.2 meters per second squared. So as you can see, you have different ways to calculate the acceleration. We can use acceleration is v squared divided by r, acceleration is equal to omega square r, or acceleration is equal to omega multiplied by v. An object completes 60 rotations in 1.25 minutes. Calculate its frequency, its period, its angular velocity. Take pi equals 22/7. Solution: the number of rotations is 60 rotations, and the total time taken to perform those 60 rotations is 1.25 minutes. We can convert that to seconds by multiplying it by 60. That will be 75 seconds. we are instructed to take pi as 22 over 7. So moving on to answering the questions. Question 1 asks us to find the frequency. The frequency is equal to the number of rotations divided by the time, that is the total time. So that is going to be 60 divided by 75. And 60 divided by 75 is 0.8. So that is 0.8 hertz. Question 2 asks us to find the period. So the period is the time taken to perform one rotation or one revolution. And it is the inverse of the frequency, or the period can also be the time divided by the number of rotations. So try not to confuse these two. Frequency can be the number of rotations divided by the total time, but the period is the inverse of that. So it will be the total time divided by the number of rotations. So if we should go by that, we will have 1 divided by the frequency is 0.8. So 1 divided by 0.8 is 1.25 seconds. If we want to use the other formula, the total time is 75 divided by the number of rotations is 60. 75 divided by 60, you will still have the same answer, 1.25 seconds. Okay, any of the formulae that you want to use is applicable. The last question is asking us to find the angular velocity, omega. The angular velocity is equal to 2 pi f, or you can use the angular velocity is equal to 2 pi divided by the period. So if we should use the frequency, that will be 2 times pi times the frequency is 0.8. So 2 times 0.8 is 1.6. So that will be 1.6 pi radians per seconds. All right, where we instructed to take pi as 22 over 7 years. So let's try to substitute that. So that will be 1.6 times 22 over 7 radians per second. 1.6 times 22 over 7 is 176 divided by 35 radians per second, or approximately that will be 5.03 radians per second. Okay, so if we want to use the other formula, which is 2 pi divided by t, that will be 2 pi divided by the period is 1.25, right? 1.25. So 2 divided by 1.25 is 1.6. So we'll have 1.6 pi. And if we should substitute the value of pi, that will be 1.6 times 22 over 7. 1.6 times 22 over 7, we will still have 176 divided by 35. So that will be radians per second, and approximately that is 5.03 radians per second. A spherical object of mass 500 grams attached to one end of a string is revolving uniformly in a horizontal circle of radius 84 centimeters. The object completes 25 revolutions in 20 seconds. Determine the linear velocity and the centripetal acceleration of the object. Take pi as 22 over 7. Solution. The mass of the object is 500 grams, which is the same as 0.5 kilograms. The radius of the circle is 84 centimeters, which is the same as 0.84 meters. The number of revolutions is 25 revolutions. And the total time taken for those revolutions is 20 seconds. So we want to find the linear velocity and the centripetal acceleration. Well, when you have the number of revolutions and time, you can find the frequency or the period. Okay, so the frequency is equal to the number of revolutions divided by time, and the period is equal to the total time divided by the number of revolutions, because the frequency is the inverse of the period and the period is the inverse of the frequency. Okay, so whichever way you want to state it. So the number of revolution is 25 divided by 20, and 25 divided by 20 is 1.25. So the frequency is 1.25 hertz. If we want to find the period, that will be 20 divided by 25. 20 divided by 25 is 0.8 seconds. Now let's try to see what we can find. If we want to find the velocity, that is the linear velocity, v, is either we use omega r, or v is equal to 2 pi fr, or in terms of period, v is equal to 2 pi r divided by the period. So if we want to use the first formula that I have given, v is equal to omega r, it means we need to know the angular velocity. If we want to use v equals to 2 pi fr, we should have the frequency. Or if we want to use v equals to 2 pi r over t, which means we should know the period. So is there any way we can find the angular velocity? Yeah. The formula for angular velocity is that angular velocity is equal to 2 pi divided by the period. Okay, so if we use that, we're going to have angular velocity equals to 2 pi divided by the period is 0.8 seconds. So 2 divided by 0.8 is going to be 2.5 pi, okay, radians per second. So with that, if I want to use the first formula as v equals to omega r, the omega is 2.5 pi, then multiply by the radius is 0.84. So 2.5 times 0.84 is going to be 2.1 pi meters per second. So if we want to substitute the value of pi, that will be 2.1 times 22 over 7 meters per second. 2.1 times 22 over 7 is 6.6 meters per second. So that is the linear velocity, is 6.6 meters per second. What if we want to use v equals to 2 pi fr? That's straightforward. So v equals to 2 pi fr. That will be 2 times pi times the frequency. We have it as 1.25 times the radius is 0.84. 2 times 1.25 times 0.84 is 2.1. So that will be 2.1 pi meters per second. So if we substitute the value of pi, that will be 2.1 times 22 over 7 meters per second. 2.1 times 22 over 7 is 6.6 again. So 6.6 meters per second. So whichever formula works for you, you just stick on that. Using V is equal to 2 pi r divided by t, that will be 2 times pi times the radius is 0.84. Then this is divided by the period is calculated as 0.8 seconds. So 2 times 0.84, the answer that you have, if you divide by 0.8, you will have 2.1. So that will be 2.1 pi. Again, if you substitute the value of pi as 22 over 7, you end up having the same answer as 6.6 meters per second. Okay? So moving on to answer the centripetal acceleration. The centripetal acceleration, we said that we can have acceleration is equal to v squared divided by r, or acceleration is equal to omega square r, or acceleration is equal to 4 pi square r divided by t squared. Okay, so any of these formulae could give you the answer. All right, acceleration is equals to v squared divided by r, acceleration is equal to omega square r, and acceleration is equal to 4 pi square r divided by t squared. We have derived all of these formulae in our previous videos, so you can watch them. So if I should go by the formula, using acceleration is equal to v squared divided by r, the velocity is 6.6. So that will be squared divided by the radius is 0.84. So 6.6 squared is 43.56 divided by 0.84. That will be 51.9 meters per second squared. Okay, so if at all I want to use acceleration is equal to omega square r, that will be the omega is calculated as 2.5 pi, right? 2.5 pi all squared multiplied by r is 0.84. So what is 2.5 squared? Is 6.25 pi squared times 0.84. 6.25 times 0.84 is 5.25 pi squared. So we'll have 5.25 times pi is given as 22 over 7. So that will be squared. Now we will have 5.25 times 22 square is 484 divided by 7 square is 49. So if you do that calculation, 5.25 times 484, the answer that you have divided by 49, you will have 51.9 meters per second squared as the acceleration. And finally, if we want to use acceleration is equal to 4 pi square r divided by t squared acceleration is equal to 4 pi square r divided by t squared. Here we go, we'll have acceleration is equal to 4 times pi square times r, that is the radius is 0.84, divided by the period. We calculated that as 0.8 seconds, right? 0.8. So we need to square that, okay? So acceleration will be equal to 4 times 0.84 is 3.36. So that will be pi squared divided by 0.8 squared is 0.64. So acceleration is equal to 3.36 divided by 0.64 is 5.25 pi squared. So acceleration will be equal to 5.25 times, when we substitute the value of pi as 22/7 and square it, we'll have acceleration equals to 5.25 times 22 squared is 484 divided by 7 squared is 49. If you do that math, 5.25 times 484, the answer that you have, if you divide by 49, you will have 51.9 meters per second squared as the acceleration. Well, thank you very much for watching this video. Please subscribe to the channel, like and share the video. Okay, I have tried all my best to explain all the concepts regarding the calculations involved in circular motion. If you have not watched my previous videos, please try to watch the videos on circular motion so that you can understand it systematically. See you soon in our next video.